What if I told you there is a crazy, user-friendly, easy DIY way you can go off the grid? What if I told you you could build your own Jackery type power box with a lot more storage for far less money? Well, that's what we're here to talk about today, so stick around and I'll tell you all about it. All right, so welcome back. I'm Gary, for those who don't know. Today we are here to talk about the Goldenmate LFP12200 batteries. These batteries are kind of a game changer in the world of off-grid power, solar power, mobile camping. You name it, you can make it happen with this. So what this is a giant 200 amp hour, 12 volt LFP12200 battery. LFP12200 is the newest, safest, most advanced version of lithium type batteries that we have out today, being rechargeable. But you can't just buy this box and plug a house outlet into it. I mean, suppose we could try, I guess, but it's because there's no plugs on it. So first, let's talk about what this thing has, and let's talk about the differences between this and one of the other power boxes we've already checked out. All right, so coming right in the front here, you got the model number, not the most important number at this time, but you can see here, 12.8 volts, 200 amp hour, a total of 2,560 watt hours. Now for comparison, this is the $500 to $600 Bluetti. This is a 681 watt hour battery bank. Super useful, super portable, great unit. But what if you want more capacity? Do you want to just go buy multiple of these boxes? But what if I told you this solution right here, paired with a couple of other parts, can have over 4 times total allotted power for barely more than the cost of this. So what we're going to do today, we're going to talk about how to use this with some other things to make your own version of that. Now, keep in mind, this thing does weigh about 55 pounds. With these straps, it's pretty easy to pick up. But it's not as easy to carry as those smaller boxes, but Goldenmate does offer other options. I chose this size because I think this is going to be great in a future vehicle build. What do I mean by future vehicle build? Well, it'd be super nice to have a whole bunch of power in a vehicle you take camping, a whole ton of accessories. Or if you make YouTube videos, you got to be able to record somewhere, am I right? So first, let's jump into the specs of this thing. Then we're going to get into this box and see what you got to do to make it usable for you. All right, so jumping right into the stats. Let's get started right in the front here. So this is a LFP12200 battery. That stands for lithium iron phosphate. That's one of the newer lithium battery technologies out today. They're great, they're reliable, they're about as good as you can get for your everyday use. First thing we're gonna look at here, we're gonna check out the charge voltage. This is important, charge voltage. 14.4 volts, 14.6 max. Basically, in order to charge this thing, you're gonna wanna do it a couple ways. One, you're gonna wanna use a specialized charger from a solar type system, type of battery setup, or got this right here, or you can use something like this. This is an older one, this is a NOCO Genius, but if you look here, it does say it's good for 12 volt lithiums. Now, this does not mean that it's going to be good for all 12 volt lithium batteries. A lot of these newer NOCO Genius chargers will actually say straight on them, LFP12200. Make sure to check the manufacturer's specifications. Back to the stats here. So if we look down here, we can see right here, charge current, 40 to 100 amps. So you can charge this thing at 100 amps. So you can charge this thing up to 100 amps. Now, continuous discharge current. This is where it gets important. These are the numbers you're really going to want to pay attention to. Continuous max discharge for this is 120 amps. That is a lot higher than I expected. Now, given that is if you're running one. If you start going to series or parallel, depending on how it goes, you can have more, you can have less. There's a whole bunch to it. We'll throw a chart up right here. Coming in next, also something you should pay attention to. You have your operating temperatures, right? You can charge it down to 0 degrees Celsius or negative 20 degrees Celsius on the discharge. So that means if it's about negative 4 degrees Fahrenheit out, you can still be using this thing. You can take it out cold weather camping with you, but if it gets much lower than that, you're gonna have issues because inside of here, there's a lot more than just batteries. I don't plan on taking this one apart, but the inside of these are quite impressive. All right, so first, let's slow down for a second. Lithium batteries, BMSs, there's a lot of different technologies and information being thrown around here. Let's start real simple. This is an 18650 lithium ion battery cell. Essentially inside of this box, there are dozens of these stacked up in here and linked together. Usually they're welded together with a type of nickel cadmium strip. And then in between each block of these, there is a charge wire going to the actual BMS. So let's look at this another way. This is your higher end e-bike battery right here. Up here on top, there is a control board and a bunch of wires. So then you have a whole bunch of wires coming off. The job of the BMS, now keep in mind, this is not the one that's inside here, this is just a small one, so I can kind of show you guys what's going on. So inside of this little control board is basically a processor, a chip that's going to tell it how to charge these, when to charge them, when to not charge them, so it's going to monitor a few things. One, over voltage. If you overcharge voltage on LiFePO4 lithium batteries, well, they get dangerous. They can explode, so you need a good BMS. Another thing, right here on this side, you can see these little cables. A couple of them came off. These are temperature probes. There are a few of these in here too, because again, you have these specifications down here for charging. You don't want to charge it too high, too low, discharging it too high, too low. All of that stuff can not only be somewhat dangerous, depending on the overcharge and stuff like that, but it can also damage the life of your battery. So it's very important to have a good BMS system set up, and this one really does. It is phenomenal. Now let's talk life cycles. This thing is designed to run at 100% power for 5,000 cycles. Now, to put that into comparison, your average car battery is usually good for anywhere from 200 to 500 cycles. What a cycle means is the amount of times you discharge the battery, charge it back up, right? This one will go up to 5,000. So if you were to recharge this every single day, that would last you nearly 14 years, still getting really close to 100% your initial capacity, which is just mind-blowing. That being said, once you hit 5,000 charges, the thing's not just going to die in you, but eventually the internal battery life of these little lithium ions here, they degrade, they go down. So this one here has, well, it's got a management system. Honestly, all smart cars and a lot of other technologies do this already. Basically, they, over time, lose a little bit of storage in the battery, lose a little bit of space, they can put the juice per se. This thing here is also rated to run up to 15,000 cycles at 60% of the original capacity. So one charge a day, 15,000 cycles, you're talking almost like, what, 42 years? That's pretty crazy. Okay, enough of the crazy spec sheets and numbers. I just want you guys to understand that this thing is phenomenal. Oh, and for the price, right now it's on sale, $522. So it's actually coming in cheaper than most 600 to 700 watt hour battery banks. But now I know what you're thinking. I know you're thinking. Those you can plug in. You can use them right away. They're simple. They're compact. You're right. But if you want the best bang for the buck, that's when you pair with this next box. So let's slide this over for a second and check it out. So this is a 2,000 watt, 12 volt inverter right here. So the whole job of this thing right here is to turn these two little posts right here into power. And check out the size comparison. It's almost like I thought that through. I kind of did. It's a little more complicated than that though, so let's dig in and see what else we have. So inside, we're gonna have these big old gauge wires, because if you're trying to run 2,000 watts, you do not want to go with smaller wires. It becomes an extreme fire hazard. Don't do that. So these right here, these are 4 gauge wires. All right, so right here, as you can see, it already has the connectors on there, nice, clean, crimped, covered. So what do we do with these? So if we unscrew our little cap here, we're gonna have a threaded end. I believe they're usually M8s. In this case right here, we run this right through here. Now keep in mind, if you're running a normal charging system, whether it be solar or anything else, this is also where that's gonna go. They're gonna be connected together here in the same spot, because most inverters, like this 2,000 watt that I have here, they're not going to have a type of charging solution built into them. Normally that's something you're gonna handle separately. That's why I showed you guys the NOCO. So if you want a way to just charge this in the house, keep it around as a backup battery in case the power goes out, you're gonna need one of these for sure, or something similar. I'll make sure to put the prices and the links up of everything. So, coolest part about this setup right here, boom, one, you're at 2,000 watts. You look at comparable jackeries that do anywhere near this many watt hours and this many watts, you are at, all right, we'll slow down for a sec. Let's get into the full price of this. $522, $169. So after tax and shipping, we're gonna round up. We're gonna say it's $700 for this current setup. Now, if you want an external charger because you don't have solar, you're probably gonna need one. So we'll throw this guy in right here. These are about 55 to 60 bucks, and this is a really good brand. There are probably cheaper ones out there, but you gotta be careful. This is charging equipment. So with this setup here, what can you do? Well, my gaming computer runs a 1200 watt power supply, an RTX 3090 Ti, crazy amounts of power. This will run it for quite a long time. Probably one of the biggest benefits to these batteries here isn't even the battery itself. It's what you can do with many of these batteries. You can build yourself an entire off-the-grid system for a cabin, a house, a vehicle, whatever you want, because you can pair up to 4 of these together safely. Basically, it just comes down to your use case. This in here, 12 volt to 110 volt, very simple, 2000 watts. So think of anything 2000 watts that you have that you want to power. That's what it'll run. So my main reason for showing you this, 2 reasons. One, Goldenmate wanted me to do a video on it, so they sent it over. I have this weird obsession with external power because I find it fascinating and extremely useful. This is going to make a place. This is going to be installed in one of my vehicles, my truck, something. It's going to be involved in camping. You're going to see these again. If there's something else you guys want to see, let me know. Throw it down in them comments below. I'd love to talk about it. I love DIY projects. I love trying out new things, doing new things. I'm pretty familiar with power, so I'm pretty comfortable working with this stuff. But what do you guys think I should do with this first? Okay, we're back a couple days later. I had to get a few parts, and let's just say I still don't quite have everything the proper way, but I have enough to show you guys the basics on how to hook up a monitoring system and basically just kind of see what's going on, check out your overall voltage, current, total capacity, all that kind of stuff. So first off, let's slide this out of the way. When you're hooking up these different types of cables, or if you want to hook up some kind of monitor like this is a wireless shunt monitor right here. Basically what we're going to do, there's a dozen different ways to hook this thing up. Like just looking at the owner's manual, there's a lot going on. But what we're going to do, we're going to run the ground cable in line with this shunt mod, basically just to get the numbers we're looking for. So in order to do that, your typical inverter is usually going to come with a positive and a negative cable, right? And the cables are going to be specific to basically what the inverter recommends. You're always going to want to follow manufacturer recommendations for sizes on these cables. Very important safety-wise. What we ended up with was actually a 3-gauge wire from Home Depot. Now, would it have been smarter to order this stuff online? Absolutely. I also can't find my right crimpers, but it'll work just to show you guys how this is going to go. And just in case you guys are curious, for some basic D-ring connectors here, you can see they're called ring terminals. These are 4-gauge ring terminals. Again, there's probably higher quality ones than this, but this is all Home Depot had, and I didn't want to wait another few days for shipping. So it'll work for today's purposes. $2.41 a foot. I got 4 foot just to give myself a little extra here. We are not going to need all this, so I'm going to cut it in half, and it's going to give me a little extra. Again, it's certainly smarter to use the right tools for the job, but it also would be a little better if I've been using these wire cutters for years. They are not happy. So let's go ahead and see if we can't get this connected. Again, just something to keep in mind, this is a very temporary setup. This is not something I plan on leaving connected. If it was, I would be using something a little more solid, and I would definitely be trying to use the correct tools here. All right, for demonstration purposes, I got this working. I used my vice grip. This is not the proper way to do this, but these bigger crimp connectors take a special tool, and unfortunately, I can't find mine. All right, so real quick, if we take a look at our diagram here, we're going to be running with this one right down here. Our battery is going to come right in here on this side, and it's going to come out this side over here. It looks a little bit jumbled, but we went and got her hooked up. All right, so here we have the ground cable coming from the Goldenmate lithium-ion battery. It is running through the shunt mod, which is reading all of the information you'll see here on the screen, right? 13.4 volts, 100%. So run up through the shunt mod back to the load. The load right here is the inverter. Then we have the power wire connected straight to the inverter, plus this little excess sense wire and power wire, bringing power to this system, basically allowing it to work. At the bottom of the JuneTech here, you'll see a little thing that says 12 volt plus and minus. So that is an extra little cable that's supplied. So at the bottom of that is this little cable here. So if you take this cable right here, you can wire it into your own 12 volt system, and essentially turns this wireless. There's a wireless sensor on the board on the bottom of this, allowing you to place this somewhere else. So if you're doing a lot of tests, like I will be doing in the future, I'm probably gonna mount all this to a board, make it a little easier to install for future battery tests, right? So I can test actual capacity on all their batteries too, which would be kind of cool. But next, say you install this in a camper, a truck, a car, a house. You can take 4 of these batteries, you can run them together for a total of 51 volts, or you can increase the overall capacity massively and use this for like a home power system for backup power, stuff like that. You can run it through solar, all sorts of other things. Well, this is gonna be your little wireless monitor right here. So let's turn this on, see what we get. Now, on initial startup, my inverter gets a little loud. It powers up the fans. I believe it's an automatic thing, just in case it just got turned on and it was super hot, it's sitting outside, whatever reason it might be. So you can see, with just the inverter alone, we're pulling about 18 watts. Not too surprising, it's got its own little sensing circuits in there to run. It has to keep the inverter powered on when the unit is on here. We'll take a look at the side of the unit as well. You can see right down here, it shows that the inverter is on. It's using 0 external power. So let's plug something in and see what it says. Now in this unit today, we're not going to be doing a full capacity test. There are plenty of verified sources out there saying that this is every bit of 200 amp hours. Mainly, I'm going to be testing the capacity with the Junetech later on down the road when it's brands that we're not really sure of. So this is my extremely dirty 1500 watt heater. Let's see how the system runs it. You can see right on the top screen here. Let me turn this sideways for you. Now overall, it does seem like my inverter is pretty loud. I'm not sure how much this is gonna get on the audio, so we're gonna cut it off here. All right, overall, we had to give it a second, so keep in mind, a lot of inverters are gonna be pretty loud, regardless of the type. Some of the higher voltage ones, like 24 volts, they're gonna be a little more power efficient, right? But you're gonna have to wire them differently, depending on series or parallel or which inverter you get. There are tons of them. There's really expensive ones, but realistically, if you were to try to make a setup like this, a 2000 watt would be absolutely perfect. Now this unit here is capable of 120 amps, this battery itself, but realistically, if you want to get some longer life out of this thing, you're probably not going to be hitting it with loads quite that high. Considering a lot of older houses in the US still only have 100 amp panels for their entire house. So now here's what I want to know from you guys. What do you guys think I should put this in? What do you think I should use it in? Are there any tests you want to see? What would you use it for? I plan on testing a lot of these batteries in the future. Eventually, I'm going to turn this house completely solar. Not the best idea here in Michigan, but I love the technology involved in power. Batteries, LiFePO4, lithium phosphate, all of that stuff. It's very entertaining to me, and I can't wait to check out more. So on that note, thanks Goldenmate for sending this over. Also, just a quick price update. I did see it's currently on sale for $4.99 for this monster right here on Amazon. Links are going to be down below. Go check them out. I'll throw in the links to the Junetech as well as the MF-UZOP. I'll put the links down there for the inverter, but I have not tested it to a great deal. It does seem to work fine. Fairly loud, but realistically, I don't have a ton of experience with 2000 watt inverters. But overall, super cool technology. The possibilities are limitless, and I can't wait to talk about them in the comments. So until then, we'll see everybody on the next one.